Talking about DMX, the basketball shoe. Now, I'm going to try to remember to say DMX 512A every time I say it, but I'm not going to. So just when I slip and I forget that it's not, and I say just DMX, I'm not talking about either of these guys. Okay. So what is DMX? Essentially, DMX 512A, see, I did it, is a means of sending packets of information across a network. The system has some physical and size limitations. Basically, one master controller can control up to 32 slave devices on a single line. And there are ways around this and most of the other issues that we're going to talk about in a bit. As with most things digital, we're talking about binary code. So in this case, we're talking about 8-bit binary code. Each slave device needs an individual address so that the data packets can be ignored by the ones who aren't supposed to pay attention to it and received by the ones that are. And the best analogy that I could come up with is the way my teenager responds when I talk to her unless I use her first, last, and middle name. DMX is an ANSI standard, and that's actually a big deal. For any of us who have worked on projects where we thought everyone was very clear about what we were doing and what was and wasn't specified and how things were going to work together, or even just the amount of interoperability that we all thought we required, only to discover that there was a miscommunication somewhere and that someone failed to read some email. Having a nationally verified standard can be a huge help because the components are either compliant or they're not, right? And that compliance can be included as a requirement in your specification. It's a really nice black line to draw. Yes, no, in, out. The protocol was developed for use in the theatrical world. Its primary purpose is to allow components from different manufacturers to work together. Just to give a little bit of an historical perspective, A Chorus Line was the first Broadway musical to use a computer-controlled lighting system, and that was in 1975. As the theatrical world was making this transition, it was not uncommon to discover that a board from one manufacturer couldn't control dimmers from another manufacturer as well as it could control dimmers from a different manufacturer. So you had these issues where very elaborate cue sequences and things were written, and they just didn't quite work because nobody was really speaking to each other. So the USITT began to develop a formal means of ensuring this basic level of interoperability. And if you look at the productions that were being developed at the same period as the standard was being developed, one of the things that you can see is that the level of complexity and technical requirements for even our entertainment uses, I shouldn't say even, but was really expanding. The Tony Awards for 1986, which was when the USITT first published the standard as a non-binding voluntary standard, the nominees were, or included, The House of Blue Leaves, The Search for Life in the Intelligent Life in the Universe, sorry, and The Mysteries of Edwin Drood. None of those strike anybody as particularly remarkably visually whatever, except for House of Blue Leaves maybe. If you're a lighting design geek, you can think, oh wow, John Guare, that's really cool. Here's where it gets kind of interesting though. Starlight Express, Les Mis, Fences, and Les Liaisons Dangereuses were already in production and would all win Tonys the following year. So you can see where we were on the cusp of when the standard was introduced and as it starts to move forward. The problem is that USITT is not an ANSI standards partner. So, and there's a lot of, you know what, doesn't matter. They're not an ANSI standards partner. And by the 90s, it was pretty clear. It was pretty clear that the widening acceptance of this as a protocol required some really formal binding definition. So basically what they did is USIT transferred ownership of the standard to ESTA, which is an ANSI standards partner, just like the IES. And it was issued for the first time as an official standard in 1998. So just to give you sort of a scope idea, by the time we get to 1998, Miss Saigon, Sunset Boulevard, and The Lion King have opened. So we've gone from The Mysteries of Edwin Drood to The Lion King and that swimming pool. Obviously, there's some complexity expansion, right? So as our expectations of the visual capabilities and requirements for our architectural environments are expanding pretty much to the same level of the theatrical world, I think it makes sense to look back in that direction for strategies and technologies. So why a standard? The benefits of a standard-based protocol include, and in my mind are really most specifically defined by, a clear definition of what constitutes the system. So, a standard defines, among other things, the electrical interface standards. The standard specifies that a DMX512A controller is connected using EIA485 cable, so RS485 cable. That's a second standard. There's very clearly defined. And to break it down very briefly, we're talking about stranded pair polarity sensitive wire, which complies with this other standard. It's important because the decoding of that 8-bit package that we talked about is dependent on the voltage difference between the positive and the negative wires. So you have to have wires that can understand the relationship that they're dealing with. DMX512 also includes a recommended practice that limits the physical length of the total cable run to 1,500 feet. That's feet, not meters. And that's important because 485 is generally limited to no more than 3,000 feet, so it gets a little bit confusing. But the goal is that we keep these runs relatively short. So the standard also tells us what physical interfaces we can and cannot use. And DMX512A explicitly requires a 5-pin XLR connector and explicitly prohibits a 3-pin XLR connector. And this is a really good thing because mic cable doesn't transmit lighting information very well. It's just kind of useless. The standard also recognizes the use of an RJ45 modular connector for instances where there is minimal connection and reconnection, and this is what makes it useful for us in an architectural environment, right? We don't need, excuse me to my theater friends, we don't need those big clunky 5-pin XLRs. We've got this cute little RJ45 connector. Along with standards, look, more standards, more rules. Okay, so the standard is defined as a multi-drop bus technology with daisy-chained nodes. So we're going to break that down a little bit, and we're going to ask, what's a bus? Very simply, a bus is an electrical scheme to carry power or data. So in addition to the fact that it can be class 1 or class 2, and it can be rated or limited by distance, all of those things, just to give you some sort of more basic, less technical ideas. Phone lines, electrical lines, fiber optic cable, those are all examples of a bus, right? And what's a node? So within the context of network topology, there are lots of different ways of connecting aspects of a network together. DMX512 uses a daisy chain. What's a daisy chain? It's important to note that the standard requires that the bus begin with a controller and end with a terminator. So that means that in order for the system to be compliant, it really does have to have a physical end to the communication, and that's important. It can't just kind of drag off into the ether for nowhere. All right. So I want to make sure I explain this clearly. The control process within a DMX512A system is broken down into 256 steps. It literally goes to 11. One of the primary reasons to specify a system is the level and intense granularity of control that it can provide. This allows for minute alterations of the controlled light source and is directly related actually to the binary nature of the code that the standard uses to transmit data. So data in a DMX system is transmitted in simple asynchronous 8-bit serial protocol. I think simple is a little bit of a misnomer, but we'll go with it. Essentially, that means that there are 8 slots into which zeros and ones can be inserted. And this provides for a total of 256 possible combinations. 0 is off, and 255 is full on. It means that anywhere between off and full on, whatever that means for the particular aspect of the luminaire or device that you're controlling, you have 250 steps in between there. you can actually then combine channels for even more granularity of control. And in the case of RGB color space, this provides the opportunity to tune color on or off of Planckian values and beyond those that are readily visible. So what that means is in circadian entrainment situations, this can become really useful because sometimes we're not really talking about the light that we see, we're talking about the light that the non-visual parts of our eyes see. A universe is made up of 512 addresses. The intense granularity with which the multiple facets of a single luminaire can be manipulated is, as I said, it's the main reason to use DMX. It's useful within an architectural control environment because a single luminaire can have up to 16 individual addresses. Now, I can't think of 16 aspects of a single luminaire I would need to control, but I can think of 4 without a whole lot of trouble. And I'm sure that as we move forward, there will be others. And now I've lost my place. That's good. Okay. So the best non-lighting analogy that I can offer is that about why this granularity is important is that a diamond is more highly valued by the number and complexity of its facets. So it's basically, we can really get into a micro level in terms of what we're looking at and what we're controlling. Okay, so how is all of this used? I want to stop a little bit now talking about DMX and just talk about control systems in general so that we can understand how this particular protocol fits into our understanding of the architecture of lighting control. All control systems basically have the same components, okay? On the front end, there's a stimulus that starts the whole sequence. This can be input from a sensor, it can be interaction with a keypad or switch, or a command based on an astronomical time clock, or some other external actor, it doesn't really matter. On the back end, there's some sort of interface that translates the command signal into an action, or in our case, by sending a series of 8 zeros and 1s in a specific order and at a specific voltage. Right? Then there's the power source and the structural and mechanical support for the power equipment. That's the panels, the breakers, the dimmers, and the switches. And there's what I like to refer to, my big finish, sorry. Okay, there's what I like to refer to as the brick or the box, okay? And that's the driver. It translates the electrical information into the form that a light source can use. It's the ballast, it's the transformer, but for our purposes, since we're talking about LEDs, it's a driver. Now's my big finish, there it goes, boom. And of course, there's the light source. All right, so there are seemingly endless ways, number of ways to control LEDs. And there's nothing, I want to go out and say right now, there's nothing inherently wrong with any of them. But it's really important to know a little bit about their characteristics so that you can understand why you're making one choice over another. So let's look at 0 to 10 volt for a second. It's an analog control protocol. It interfaces with the LED driver with 2 sets of wires. That would be the black and white and the purple and gray. It can be class 1 or class 2. The line voltage switches the driver on. Low voltage provides the control signal, purple, gray. And voltage drop can be an issue because we're dealing with low voltage, and we all know that voltage drops faster on a low voltage system. So all of this is pretty straightforward, except for one small wrinkle. There are 2 0 to 10 volt protocols, and they're not compatible. And they're both called 0 to 10 volt. Okay, so there's one, which is current sync, in which the driver provides the control voltage and the dimmer is part of the driver. And then there's the other one, which is current source, where the control provides voltage for each channel and the dimmers are separate. One of the most important things to know is that in current sync, the minimum output is at 1 volt, and in current source, the minimum, off is at 0. So one is 0 to 10 volt, and one is off plus 1 to 10 volt. But they're both called 0 to 10 volt. So what does this mean? This means that somebody, some mysterious person, ideally the fixture and or the control manufacturer, needs to be aware of which standard their version of 0 to 10 volt is compliant with, and needs to make sure that that information is provided down the chain so that all the components can operate together. It's also why, as specifiers, it's really important that if somebody says, oh, we do this with 0 to 10 volt, you say, great, sink or source. If you can just remember to ask sink or source, you'll avoid a world of problems. Okay, so we also have phase control. There we go. Phase control systems are really popular because they provide control without a separate communication link. That can solve and prevent a lot of issues, especially in retrofit applications where pulling additional wire is not really feasible. The way a phase control system in general works is that it cuts into the sine wave for a predetermined amount of time. Or, to put it another way, phase control dimmers interrupt the power to the lamp and reduce voltage, which in turn reduces output. The visible output of the light is the result of the length of delay or how much of the wave is prevented from reaching the source. And as you can see, there are two phase control versions. There's forward phase or leading edge, and there's reverse phase or trailing edge. And really, the main difference is whether the cut in the wave comes before the peak or after the peak, right? So in forward phase, it's at the beginning, and in reverse phase, it's at the end. So again, this requires that somebody, this mysterious somebody that I keep talking about, is going to take responsibility for making sure that all of the components in the system are compatible and that everyone is talking about the same thing. Even if your driver is phase adaptive, somebody needs to know what that means and needs to check it out all the way through the line. And we have PWM, pulse width modulation. So PWM, in my more sarcastic moments, I like to say that PWM is a control method based on flicker. Because basically what it does is it turns the light source on and off really, 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 really fast, theoretically faster than you can see it. And the time averaged current that arrives at the LED is what determines the intensity. The idea, the idea is that it's perceiving the average, that the human eye is only perceiving the average based on how much, whether you're at the 100% cycle or the 50% cycle. PWM can be used to control both intensity and color, but there's still this issue for who's going to make sure that everything will cooperate. And also, as far as I'm aware, there's no non-proprietary means of controlling placement along the Plancking curve that uses PWM. There may be one out there, but I haven't run across it. It's all proprietary, and to me, that's an issue. So why are all of these non-issues with DMX 512A? Because ANSI and ESTA say so. I mean, because it's a published standard, DMX 512A has a more constrained list of properties, and therefore it's significantly easier to be confident that everything will work together. That is, after all, the reason that the whole standard, that's why we're here. The standard was developed so that things would work together. Now, I'm not advocating the sole use of DMX as a control protocol. There are real limitations about what it can and cannot do, and this is by design. Not every luminaire is best controlled this way, and there are some legitimate pros and cons to be examined. So what I'd like to do is take a little bit of time to look at what I hope are equivalent pros and cons. So on the pros side, we have a stable protocol that's designed to make products from different manufacturers work together, and it's been refined and reapproved for over 30 years. On the con side, it's old technology, which seems a little odd since we're working on this cutting edge technology in terms of how we're integrating lighting into a variety of different situations and how we're looking at lighting and its effect on human health and human behavior. There are less gray areas than in other methods, right? The written standard means that you're either there or you're not. But that written standard can cut both ways, and there may be some front or back end components that you really like that can't be used because it just can't comply with the standard, which is what gives rise to this idea that DMX requires special equipment. It's true, not everything will comply, but that's kind of the point. So this is a technology that was designed for mission-critical live performance, right? Every cue in a live theatrical performance is important because everything cascades down. As we look at more environmental uses of lighting technology, that also becomes true for us within the architectural world. But it's also true that not every conference room needs this, right? The one conference room with the 4 offices that feed into it, it doesn't need all of that, which is fine. Use some other means of control. The old school nature of the standard means that there are relatively few places to look when problems arise, right? It's a hardwired system, and there's not a whole lot of places. There are few components. And in my mind, the more straightforward and streamlined that we can make the troubleshooting process, the better. The development of RDM, which stands for Remote Device Management, as an ancillary standard, allows for a second layer of query and response within DMX 512A network. So if you really do need to have bidirectional communication, you can. Oops, sorry. There we go. Okay, and we now have available the beginnings of a wireless DMX standard, which can be contrasted by the idea that wireless is always better, right? So wireless DMX systems have gradually developed to allow data packets to travel via what are essentially custom radio stations or radio links with a reliability that is beginning to approach that of the wired systems. Basically, this works by adding a transmitter into the daisy chain, which receives the wired DMX signal or packet sequence, and then the transmitter broadcasts that packet out to receivers, which then transmit them on to more wired components. This is one of the ways that that we can extend beyond the 1,500-foot cutoff, and it's also useful to bridge gaps where wires are just not really an option. So there are inherent issues with wireless DMX systems because it is a fix. But it's also worth remembering, and this is where I think this is really critical on some level. It's worth remembering that a wired connection, will always be more reliable and faster than a wireless one. If you've ever tried to download a program over Wi-Fi, as opposed to actually plugging in, you've seen this firsthand. Your download time goes from 4 hours to 40 minutes, right? So it's appropriate to carefully consider and balance the efficacy, costs, and limitations of each system individually when considering what and how to specify. So to sort of wrap up, controlling LEDs is complicated. We know that, and there's a tendency as each new means of control is introduced to be both overwhelmed and to some extent distracted by the shiny new toy that's being offered to us, especially if the bagels are good. It's our job as specifiers, though, to be somewhat resistant consumers of the marketing and to think through the specific control requirements for each of the luminaires that we specify and each of the projects that we work on, especially as we're coming into this space where SSL sources are so much the norm that we have one source throughout the project, right? Most of us, some of us, can remember when there were at least 3 standard lighting sources on any standard specification. That's not really true anymore, right? By and large, everything is the same, well, but not. So it's important that we specify control systems that are complex and multifaceted on the back end and seamless and intuitive on the front end. And honestly, when I look at that, and I sort of looked at that sentence as I was putting this talk together and said, I don't really think that the mandate has changed that much from the legacy sources that we're all more familiar with. Our job has always been to specify complex back-end systems and simple front-end systems because the simple front-end system is what gets used, and the complex back-end system is what allows our effects to happen. And, oh, there's an official ending slide. There's an official ending slide. Thank you. Questions? Yeah, Mr. Ferris.
This is a great talk. I have to ask you, when you're looking at the comparison between analog and digital, which is basically what you did, why you did not also compare DMX to Dolly or other digital?
So I think that's a really valid question, and the reason is because for whatever reason, I like Dolly. But for whatever reason, Dolly just really didn't catch on. And it's just not what's out there. What's out there, well, it's not what's out there in an open, non-proprietary way. There are some Dolly systems, but they're proprietary and they comply with 80, 90, maybe even 97% of the standard, but not necessarily all. So when I was looking at digital systems, I really was looking for a system that would allow multifaceted control and was also manufacturer neutral. So that's the answer to that question. Anybody else? Yeah.
Do you think, just out of curiosity, going down the line, now that DMX is becoming more of an accepted architectural standard, that eventually RDM will be used as well?
You know what? I have no way of predicting that, but I would assume so. As long as the standards model is followed. That is, as long as people are willing to submit to, and I sit on another committee, on an IS committee that's working on an ANSI standard now, and the way in which these things have to be submitted, modified, questioned, and answered, it's a daunting process, and I really can understand why, any number of reasons why somebody would say, you know what, I'm done with this. But as long as people are willing to continue to go through that process so that we have a very clear definition of what is and isn't, then yeah, I think RDM will eventually get there. Okay, I was either so complicated or so clear. Nobody else has any questions? Yeah?
Just a question. Do you know who other manufacturers makes the wireless DMX?
I know there are a number of them. Some of them are upstairs today, but I have not, and I do know that there are a couple of manufacturers who have a proprietary wireless DMX system. I'm sure that there are any number of manufacturers upstairs that would be happy to point you in the right direction. Yeah.
Why are manufacturers still putting the 3-pin XLR on their products?
Do you want my professional, like, controlled answer or the real me answer?
Both of them.
They're stupid. I mean, it's just, I don't know. The 3-pin XLR, effectively prevents you from being compliant with DMX. So why you would continue to use it is kind of beyond me. I mean, I guess 5-pin XLR cable is significantly more expensive than 3-pin, and it's harder to, 5 solders are harder than 3 solders, but yeah.
So from a lighting center point of view, what would guide you to select DMX over 010?
Oh, so I feel, this is my personal thing, but anytime I need to control more than 2 aspects of the same luminaire, or 2 or more actually. So if I am doing intensity and color, if I'm doing intensity and position on the black body curve, or if I'm, as is sometimes the case, doing intensity, position on the black body curve and color, then that would be the reason. When I need that granularity of control. As I said, I can't come up with 16 aspects of a single luminaire I would need to control without adding movement in. But actually, if you start adding movement in, you could probably get to 16 pretty quickly. So yeah, every time I use a gobo changing, color changing, black body, inherently moving thing, that's when I go for DMX. No, seriously, anytime I need to control 2 or more, because to two 0 to 10 volt drivers for one fixture seems to me just an odd way to do things. It doesn't make any sense in the way my brain works. I'm sure that there are people who could better explain it than I, but to me, it just doesn't parse out. Yeah. Go ahead.
If the ANSI standard allows DMX with an RJ45 connector, does it specify a pin out?
It does. It's very specific, and it's on page 8 of the standard, I think. It also, by the way, specifies for, it has a sentence in the RJ45 paragraph about minimal plugging and unplugging. Like, there's a whole thing about when it's appropriate to use it and when it's not. It doesn't say if you're going to have to repin it more than 5 times or replug it more than 5 times, but it does say specifically for instances where there's not that much change going on. So, yeah.
Does the standard specify the behavior of the fixture when the signal drops out? Like
Whether it goes to full or whether it goes off?
or remains
I don't remember, no. My in-house DMX experts from the well-known control manufacturers say no, it does not. Anybody else? Yeah.
Using the DMX, does it make the larger picture of interfacing with the DMS easier?
I don't think it matters. I think it's another component that needs a gateway. I mean, the way that we interface with a BMS system is we have a gateway that allows one signal to be translated to another signal, and I don't really think that a gateway cares if it's translating from French to German or from French to English. It's still just translating. It's the same. Wow, it's a little daunting to look at all of you and have none of you say. So, okay, are there any other questions? Great, thank you very much.